So what about energy advice? Some participants already know us. However, for others, we are a company which do consultancy services, also produce cloud solution and desktop solution, IT solution for district heating companies, and create digital tools to increase efficiency and sustainability. What are challenges for the district heating companies? In fact, upcoming challenges, or in Western Europe already existing challenges, is to go to a low temperature district heating operation, integrate renewable energy resources, involve heat recovery schemes as an energy producer, and also reduce CO2 emissions. When we come to the company, and real project example, when we came to the company, particular we found and why we made decision to work with us, because of heat demand reduction due to climate change, and building renovation was very intensive in the city. The city had, or the heating company had, uncertainty on network conditions. We had requirement to increase heat production efficiency. We had also high maintenance cost. We had uncertainty of future investment, costly human errors, requirement to connect renewable energy sources, and high heat losses in the network. Okay, when you're talking about the high heat losses, it depends on the regulator, but from their perspective, it was quite high. So we found these challenges, and we faced these challenges, and that's why we made decision to work with us. And what we found when we came, so no GIS data model was available, so we had to build this model. No smart meter at the consumer side. We had only data collection at the end of the month. Supply temperature higher than 70 degrees, low return temperature quite good, quite low, and high OPEX for the maintenance, and operation was done through temperature control according temperature schedule, according environmental temperature. So what we did for this journey, step by step, data collection first. So we collected data and visualize it in our platform. We did inventory. We inventorized GIS data, data about not only the district heating company, but also about the consumer side, heat exchangers, also about the boilers of production of the heat. We develop a digital model, it's called like a digital twin. We run it with digital twin model online real time. So thermal hydraulic calculations are now running each hour. So we and a solution is capable to provide optimum set point for the boiler output, temperature output, and according to the heat demand, according to the heat consumption forecast. At this moment, operator of this heating network knows what would be energy consumption next hour, next 4 hours, next 24 hours, next 48 hours. So operator is capable to schedule operation of a boiler and optimize automatically through this platform, SaaS heating platform operation. And now we operate this heating network according to optimum set points. This make impact on the CapEx and OpEx also, and there is better opportunities to integrate more renewable energy sources. So, in fact, if you're coming back to the architecture of the cloud solution, This cloud solution provides you full IT solution, including mostly everything, including, for example, data collection from the boiler system and separate project, SaaS boiler project, which could optimize operation of a boiler. We are capable to collect data from the smart meters. We are capable to provide solution for the online GIS data and thermal hydraulic calculations real time each hour, connection to the accounting system, and also maintenance scheduling according to predictive maintenance or maintenance according to the need to do. And in fact, one of the newest approaches, when we have digital twin model and we have smart meter data, we are capable to understand about the metering calibration and precision and make extra scheduling if it's required. I see question. Please give more explanation how the digital twin model was performed and which platform, how much data used and how much time consumed. Yes, and the digital model is done on energy advice solution, the software called EAPSM Hydraulic. This solution, I don't remember where is the picture. I would come with picture. Yeah, this is EAPSM Hydraulic software. And in this software, we are capable, we have GIS, we are capable to run calculations each hour. And what data is needed? Data is needed about loading, heat loading. I mean, both it's hot water consumption, heat preparation, heat consumption for what? Hot water preparation and heat consumption for the heating. So we have two, both forecast, water consumption, hot water consumption, and heat consumption forecast. And we forecasted data for each metering device. I mean, one metering device could cover a couple, maybe 10 or 20 consumers, but I mean buildings. So for this building, for this metering device, we forecast energy consumption. And this energy consumption each hour results are involved to the model, GIS model, and the thermal hydraulic calculation are done. So the data is related to each consumer, each metering device, including boilers also which produce. So we are able and we do scheduling also different, for example, in the network operate not one boiler but couple, 3, 4 boilers. So we can schedule which prioritize boilers which produce energy first, which second, which is play a role of balancing energy, and etc. So digital model through EAPSM software, energy advice power system modeling software. What is specific of the software, why we are really capable to run automatically data analysis? Because we have opportunity and we have capability to simulate heat load as a in the model as a heat load and also valve operation. I mean, flow adjustable according to heat consumption as in real network. That's why we are capable to simulate at the same and compare, and we have very high precision of analysis, very low calculation error in comparison with real situation, because we have in fact full description and full model, full description of system. Forecast, heat consumption forecast, heat production also forecast, and operation control through production control. This is difference. Usually when old approach, we operate network according to, we control temperature. In fact, if outside it's -2, we should apply supply temperature like 70, whatever. degrees. So, but in this case, we have a different approach. We control production according to demand, maintaining required temperature. I mean, for example, to prepare hot water at right temperature due to Legionella issue, for example. So we need some temperature, not only power capacity, heat power, heat capacity, but also temperature required. And for the heating also, we have requirement at the consumer side to have temperature to deliver, to transmit heat energy from the hot to the cold side. So we changed that approach, control through production, but instead of through temperature. And so finally, this increase efficiency. How? Because real calculations show that supply temperature probably it's enough to have near to 60 degrees instead of 70 degrees. But this is, you see sign, it's near to 60 degrees because it depends on the hour. So it could be in 1 hour, it's a little bit high, in another hour it could be a little bit lower, and it probably, you understand that the temperature sometimes could be less than 60 degrees, and it's still enough to deliver temperature for the hot water preparation. Less human errors, yes, and here we can make impact because when we provide set points, we understand does the operator is capable or does the system is capable to maintain the right temperatures according to the set points. And here we can see statistic less than last 24 hours, 7 days, that the error less than 1 degree. It's mostly all the time, but some time was error between 1 to 3, 1 or up to 3 degrees. What was the results? We reduced heat losses, yes, and we reduced production at the same. So we consumer have bought the same energy as required, but heat losses and heat production was reduced. In fact, we calculate a couple questions because we forecast how many energy should be delivered to the consumer. We understand that consumer behavior. I mean, we understand the consumer, is it buying at this moment the same amount energy as historical, for example, according to environmental temperature. And if the buyer or client is buying or consuming energy less, we understand and we indicate in the system that the consumer at this moment consume less energy when it's usual, according to last couple years statistic. And also we can understand that the production at the same moment with less or higher energy consumption is less or higher according to last couple years statistic. And finally, when the consumer consume less energy, we still need to produce less energy also to have reduced heat losses. So the forecast allow us to precisely understand what is going on in this in the city with the consumers and the grid. What was also interesting that the performance of condensing economizer production was increased. So we have got some statistic. Blue dots is average monthly data from the statistic previous years, and we see now that at a higher temperatures. Performance of condensing heat economizer increased. So we are happy about these results. About the maintenance issue, we do presentation not only for Latvia, and this presentation is dedicated for Latvia, but we do also presentation for West Europe, and in West Europe is not really overpressure test performed during the summer, like in, for example, this part of post-Sovietic region. And what we found that the mechanical stress on the pipes without temperature control, without our control, is higher when control with our solution. And because we are capable to control temperature, control heat supply to the city, we were capable to stabilize temperature difference from the starting point till the end, farthest point in the city. I mean, temperature reduction or gradient, temperature gradient through a time. For example, what is the temperature difference along the pipe in all city? In all city, it's 0.25, and this is during 6-7 days, 1 week. And you can see that the temperature each hour and during 7 days, highest temperature gradient along or difference along pipe was only 0.4 degrees. And because we limited this, we limited pipe stress, we reduced pipe stress, and this make direct impact on the long life of a pipe, because you remember, if we have temperature along pipe difference, or and this difference make impact that is increasing or decreasing length of a pipe. So stabilizing this temperature, stabilize temperature and stabilize pipe length along pipe. And finally, because we have data and we probably can involve this data to analytics, and we run automatical analytics without human intervention, we are capable to have better planning. We have increased of efficiency, or reduced CO2, or reduced fuel consumption, increase personal productivity, and for the maintenance we reduce thermal expansion dynamic. And when we reduce thermal expansion dynamic, it's increase pipe lifetime. Yanis is asking how long is the pipe length all system. I don't remember, sorry. I cannot answer. I'm joking at this place, Yanis, joking like this. It's no matter how long the network is of your city, of your district heating company, because usually we always would have this temperature difference. The question is to minimize and stabilize. And if we minimize and stabilize this temperature difference deviation through the time, we stabilize operation of the district heating network. So if you're coming back to a question, what would be first, smart meters or data analytics? We come back also to the question how to start digital transformation. And in today's case, we have a lot of data. For example, we have data from a boiler house, from the boilers. We have supply side data. It's okay, data exists. Also, we have data from the consumer side. For example, just meter monthly range. And monthly data is also okay, because we can learn algorithms to forecast hourly energy consumption according to monthly data. But this create value for you, but precision always would be higher when we have smart meters. If we have smart meter which push data to us each hour, so we can train algorithms to forecast energy consumption each hour, and it's okay. If we have energy consumption each 10 minutes, for example, we can run forecast according to 10 minutes data. So that's mean that we have 6 data points of energy, temperature, in the heat substation, each six data points in 1 hour. And this is okay also, our system is capable to do. Is probably could be bad approach if we deliver from the smart meter data to the cloud, for example, hourly data each 4 hours. So it's bad. Because if we have smart meter, probably smart meter data is required, could be involved to the online data analysis and district heating network control. And finally, to answer a question, what should be first, smart meters and data analytics, we should understand business idea in general. I mean, in general, business is always looking to reduce cost. So if I reduce a temperature, I do not produce energy, but sell the same. So I earn money. I have higher efficiency. So it's profit for the company. But when I install meter and I do not use data, in fact, meter installation, buy meter install, pay for the cloud, it's just a cost, nothing more. So the question, what would be return on investment? Probably no. So in general, just metering and in big scale metering in general do not create value, except probably one value. You don't need to go to the boiler substation and read the metering device, so you save human man hours cost, not to collecting by hand data from the boiler from the client substations. But what to do next? Next is to operate system better, and this better operation allow us to integrate more resources. And so when we came to the project, we found already, and we come to the projects, it's in general, we found that control system data is available. For example, control system, boiler control system have second range data, so we can collect each 5 minutes second range data. From the consumer side, we can have metering monthly data or smart meter data. So data is available, and some extra metering devices are installed in district heating network, in district heating in the system. It's like a pressure sensors, temperature sensor, flow sensors, and already this data available, and most cases this data is enough to do something with this. To build this, run automatically, involve energy metering device, forecast energy consumption, and optimize control. And extra metering device, for example, a smart meter device at a consumer side, in fact, allow us to have just better precision. On other hand, for example, some network data like pressure, temperature, and flow meters, in fact, is obsolete. You don't need this metering device. If you install metering device at a consumer and you have second, 10-minute range measurements, you have observability of a network, what happened in the network, because you have consumer smart meter, and you absolutely don't need add extra metering device to the network. So what is the first, analytic or data? Yes, if we don't have minimum amount of meters, some from the boilers, and we cannot do analytics. But when we have this data, we launch analytics, and when we can make decision, is it enough, or this is not enough, or we need to increase precision, so we need extra metering devices. So, and the next steps, what could be next steps in general? What could be next steps? We would have push to reduce CO2. And in my opinion, digitalization in general is best way to reduce CO2. Why? Because we can, as a district heating company, you can take care about your client, how we consume energy. And if we consume surplus energy, you need to produce surplus energy, so it's CO2 emission, yeah. So renewable penetration would come probably, and not only like renewable, but waste heat recovery solution also would come somehow. Feasibility of them today under discussion, because CO2 cost still is low, but if we increase, we add extra taxes, extra cost on the CO2 emissions, we would have push to integrate all these sources. Our district heating companies are unsymmetrical. I mean, one part of consumer are close to the heat supply. Another part of the consumer is far away from the heat supply. So the same technical requirement or some technical specification for the consumer is not feasible and should be adopted to the consumer connection point in GS. And we should take into account complex approach for the maintenance issues and OPEX. As I mentioned, if we make impact on the control and optimize control, we make impact to the pipe operation, temperature operation, we make impact to the lifetime, we make impact to the OPEX. And I know many examples, many city examples where the cities have changed already pipes from the old Soviet Union time with probably bad or not very good insulation, thermal insulation, to the new pipes, and we have quite the same range heat losses. Why? We have already changed from old pipe to new pipes, and nothing happened. So in fact, these companies increase at capex, increase at opex, but nothing happened in real life, because we don't have optimum operation control. And this make the same impact on the temperature supply return. It make impact on operation lifetime of the pipes, etc. Edgars is asking how much time takes to digitalization project and when we can expect savings. Yes, it's a very good question. Usually it's 6 months. Why? Because couple months we need to just inventorize your inventory, what is in your network. Probably you have already GS solution, our competitors probably, and but the question, we import this project and we build this project in such a way that it would be possible to run automatically analysis. And so it's couple months, and another couple 3 months it's to work with you as a client on to show everything, how it's operation, how to do, how to control, and etc. So it's in general 6 months. It's good for a project, and the savings is coming after we launch. When we launch, we starting. At the same moment, we're starting to optimize, and when you become a user of a software, of a system, you operate according to system set points which system provides. SAS heating system provides you set points, and you starting to get the benefit from this. How you understand the benefit? We put them. We configure savings online calculator, and you see each hour how many energy you have saved according to last couple of years data. So we ask you data last couple of years data. And we make a configuration, and we save, telling you that at this moment you already saved, for example, 1 megawatt per this hour, or 2 megawatt, 3 megawatt per this hour, just reduce it. So you reduce fuel, and you feel at the end of the month that you reduce fuel consumption like some extent. Savings, yes. Jan is asking, do all clients need to be equipped with smart meters to understand the predict and consumption? No. If you already have now metering devices where you collect manually data, you have statistics for a couple of years. We take this data for a couple of years of each consumer, and according to this consumer environmental temperature and monthly consumption, hot water consumption, we build model which would be hourly forecast. In last webinars, I have presented that with the monthly data we can forecast and forecast error. Maximum error, it's 10% in some particular hours. So it's not like a 10% error in all 8,760 hours through the year, but it's some deviation, and it's maximum 10%, average probably 5%, and this is enough. But smart meters allow us to reduce this average 5% to average 1 to 2%, because smart meters, we have hourly data, or even each 10 minutes, and this data each 10 minutes, so it's 6 points per hour, allow us to have better understanding about the consumer and better precision, just forecast precision increase. Can we make precise enough prediction with, let's say, 20–30% smart meters and represent all system? Okay. Yes. Answer shortly, yes. Now, long answer. We recommend, for example, install smart meters. What role play smart meters? First role is you don't need person who goes at the end of the month and take a data. It's one role. Second role, we can provide you, and usually smart meter in software which collects smart meter data, you could provide you insights on the boiler house, client boiler house, yeah. Quality of the equipment. Is it heat exchanger quality is good or bad? So we can provide you insights and return temperature insights. It's high or low, but it's another story. Why you should care about the return temperature? So it's value one. Second value, if we use the smart meter data for the network control. And if we use the smart meter for the network control, yes, maybe 10, 20 or 30% of smart meters could create you better observability of the network. Observability, and that means that we have better understanding about the temperature losses at the far point in the network. For the most critical user, for example, we have the energy consumer, which is somehow industrial, like a hotel, like a spa, or what. It's critical for us. Yeah, we can have observability about the user of lowest energy demand, or kindergarten or school. So it's critical consumers and far away in the network. So we can put only metering device at that point around the network to understand big picture of a network. Even though leakages, even though changed behavior of a consumption. So Natalia is asking, what kind of smart meters would you advise to us? No matter, whatever, Chinese, whatever. From our perspective is the question not a smart meter, but the question the calculation precision in different range from a minimum consumption, because all these metering devices, ultrasonic, for example, have good behavior at the high and bad behavior at the low consumption. So or error increase at the lower consumption. So probably you should care about the installation. From installation perspective and precision, and probably if you are really thinking to involve this smart meter data for the future data analysis, please ask your vendors, or energy advice would always recommend and do collect data each 10 minutes. Next question, what is the difference between smart meter and conventional heating meters? Conventional heating meters. What do you mean conventional heating meters? Smart meters? No difference. Probably smart meters idea is that you can deliver data to the cloud somewhere, to the database. Maybe I don't understand your question, so you can describe better. Edgar, can we model different power plants in one network? Yes. Yes, answer yes. So more detailed answer would be that in the model, we model like this. Some power plants would be scheduled, or operation would be according to the cost, I mean production cost. And another part would be, and one boiler would be like a balancing boiler, because you should balance, some boilers would goes at the maximum energy production because they have very cheap energy. And another boiler would be like balancing if it's not enough, or according to dynamics, it's not. You for example, which boiler you prefer to stabilize energy production, so it could be stabilized, and another boiler, for example, gas could be in operation according to a balance mode. But this is different strategies, and each strategy which is suitable for your city would be discussed absolutely separately. I'm just telling you general strategy, what is possible to do. Which statistical or machine learning methods do you use for forecasting linear regression neural network, Yuri is asking. In fact, neural network method you don't need. In fact, it is quite enough to use. It's machine learning, yeah, it's automatic, it's done automatically, and it's not linear regression, it's more complicated. It's non-linear, and it's quite complex model, because we should involve hourly, day events, I mean holiday, some specific public holidays, and etc., environmental temperature. So model is more complex, and it's regression, but non-linear, and more complex, more complicated when just linear regression. And neural networks, probably it's not so complicated, and regression models, it's enough to perform this. Is metering period of 1 hour good enough precision? Yes, it's of course good. You should understand, yeah, it's about the time stamp or time difference between the measurements. What is the value? when we do analysis, when we get hourly data, we understand what happened during 1 hour, and this is average data. Average hourly, but in this hour could be some maximum and minimum, yeah. But if we don't need to understand more, it's enough 1 hour. But if we would like to understand more network dynamic, 10 minutes in the heat process is quite good. And it could be. In industrial application, we use 1 minute and sometimes 1 second in industrial application, because even though we are smaller, but dynamics is higher and make impact, and for a better understanding, yes. But for the maturity of a data analysis like today, it's enough to have 1 hour. Probably energy advice built infrastructure that has no limitation on the timestamp of the solution. So probably some part of meter could in your network could be for the better observability, could be 10-minute range, maybe 1 minute range, and the smart meter would behave not only like a metering device at the client side, but it would behave as a metering device for the data analytic, for the better understanding what happened in network. So you could have part of a metering device which do like a monitoring of a district heating network, yeah? But this monitoring not inside the tallest pipe, highest diameter pipe, but it make observability at the faraway point of a network. Is it complete your own solution? Yes, absolutely from scratch, from zero. Thank you, Yuris, for your questions. So, so digitalizations, yeah, here we have, and Yuris is asking about the GS component S3. Yes, it's a 3 engine inside. We have license from S3 to run this engine in and this is absolutely compatible if, for example, if you have ArcGIS GDB model, you can export data on GDB file or MDB file or whatever GIS solution is capable to export data to MDB. We can import to PSM hydraulic software to a SAS HIT solution. Support and extra connectivity platform. Yeah, we have solution online data update. For example, you are a big city and you have GIS data. Your GIS specialist is working on ArcGIS, just putting the pipes, yeah, updating data model in ArcGIS solution. And we have solution which automatically update replica. We already tested this each 5 minutes. We are capable to synchronize each 5 minutes from your ArcGIS solution replica to its standard solution with ArcGIS. Each 5 minute replica synchronized to our and update automatically without human intervention. We had a set of rules where we fix. Sometimes happen with GIS people who are responsible for the GIS, we sometimes make some general mistakes, how not to do. So we train this, but sometimes it happens. So we have also automated fixing of the GIS to run in automatically and update from ArcGIS to EAPSMGIS. Okay, do you have any questions? So the idea of digitalization is to reduce cost, not just like have fun tool to do something, but in general you should become more efficient. And more efficient, that means that IT solutions should save in general money. How to save money? If you are taking account only smart metering in general do not save money, but maybe 1 extra man hours for the data collection. But in general, higher money is related to network operation, because network operation is your main core, main business. It's operate network in optimum way, reduce OPEX, reduce CAPEX, and deliver heat, be high reliable, high available, and this is main and core of your business. What activities client, your company, yes, employees will have to do? What activities? Good question. When we start doing inventory, you provide us inventory information, GS data, boiler house data, diagrams, boiler capacity, and then it's everything, all data. When we build model, next you make IT inside configuration. I mean, for example, we take data from a boiler house SCADA control system. Yeah? So we need to connect to this control system. So you make the connection, or you ask your IT department or third-party company which do maintenance of IT solution to grant us access to the SCADA system. We install our Energy Advice data collector software, which automatically take data from a boiler house, 1, 2, 3, 5, whatever houses. So you grant access. And next we build a model, everything. We provide to you training. And at the end, some engineers, which is responsible for the planning, network operation, and etc. So we become a user of a software, and dispatcher center, which operate, we provide optimum set points. So people who is responsible for the operation and control of the network is directly involved to use the data. From a planning perspective, because we provide you energy forecast, how would be next 24 hours or next week energy consumption. So probably you need to buy a fuel. So some people which are responsible for the fuel planning, buy fuel, they can become the user, because we have a planning of how many energy would be produce and what amount of fuel you need to buy, order. And the people who is responsible for the maintenance, we have a tasker system which you push task and the maintenance activities, what you already done. So you become a user. So from the development perspective of a solution, your involvement is just to provide us data and become a user and grant access to existing IT solution. And finally, you become a user. So we, as a solution provider, we come and deliver to you solution. According to the smart meters, probably you can, if you don't have much smart meters for the smaller cities, we provide opportunities to install smart meters by themselves, and we do only integration. So we separate the smart meters buying process and implementation process from the connection to the cloud and data analytics. So we are happy to provide you data analytics if you are capable by yourself to do installation and then smart meters ordering and buying process. What savings we can expect, and can we guarantee savings? In fact, yes, we can guarantee savings, because prior to the coming to the city, we ask data, we do analysis, we trying to understand where is a problem from your data, where is a problem with your, what's the problem, like where is your cost, and how to save this cost. And we do analysis, and we calculate return on investment. And when we calculate return on investment, we expect some savings, and we expect that return on investment should be near to 1 year. for the IT solution. So you can understand that how much we can save. So it's near to 1 year. So for the reduction of losses in the pipes, heat losses, it would be probably a range of 16%, 15, 16%. It depends on the city. So at the same rule, it would be energy production reduction, and return on investments calculated according to this. Chris asking, can the digitalization method impact on return pipe temperature, so in winter stabilize it for the better flue gas condensing on economizer work? It's a question, Chris. In answer short, yes. Long answer is longer than 2 hours. Okay, so yes, we make impact also to the. You should understand that through optimum control, in fact, we can make impact even to the consumer consumption. Even, for example, we can reduce consumer consumption. If we change the temperature, supply temperature, we can make impact to the consumer consumption. So the control strategies could later would be discussed with you, with a client, how to behave. And the idea is to reduce cost. And if we see that we can reduce cost, we would tell all these options. And the impact on the return temperature more or less would be related to the consumer. And consumer, if a consumer heat exchanger is bad, so you have higher temperature return. If the consumer internal heat consumption, I mean inside the consumer building, and is requirement of very high temperature or temperature difference, so it would make impact on the higher return temperature. So in fact, return temperature mostly is impacted by consumer behavior instead of network operation behavior. But also we can through control also we can make impact, but we avoid this. We avoid through our control increase return temperature. Why we avoid? Because this is not optimum. Our goal is to optimize, so to make optimum. So increase of temperature is not optimum. Yeah. So we can make through with digital twin and control, we can make a lot of impact, but the goal is to optimize, reduce losses. Okay. Because this is a goal to reduce losses, that means that the goal is not to increase return temperature. But yes, flue gas condensing economizer operation is affected and increased. We found this. It's not, we have not expected when we calculated return on investment. When we calculate return on investment, we expect only heat losses in the pipes, and through this we only calculate. But finally we found that it's prolonged lifetime, but we have not involved to the calculation of return on investment. It's affected increased boiler flue gas condensing economizer efficiency, but we have our production increased. Yeah, but we not included this to the return on investment, and so in fact return on investment becomes even higher when we predict this. But some of them is hard to measure. What part is hard to measure? For example, if we increase lifetime of your pipes, you would see this effect only after a couple of years. So to prove this, you need a couple of years of operation and better performance of the DC heating network. Carl is asking how technically difficult is to install smart meter, and what's the price range from the smart meter? Where to see the price range for cooperation with you? How difficult to install smart meter? Our company not installing smart meters. Okay, so I don't, how difficult to install, I don't know. I'm not, maybe I know, but I don't answer this question. What's the price range for the smart? We are not seller of a price smart meter device, so we are selling you service for the analytics. So we prefer that smart meters you buy by your own, and we don't. For us, it's not important what would be supplier of a smart, what kind of smart meter, what protocol even would be for the smart meter. It's absolutely is not important for us. And the prices, yeah, we discussed to each separately, and we are ready to give you proposal with a calculation of return on investment, and because different cities solution is the same, but different cities size affect integration cost. So integration cost would depend on the city size. If smaller city, smaller cost, higher city, higher cost. Yuri's ask, so you offer a complete solution? Yes, Yuri, we provide you complete everything in one place. Should the user site plan an extra computing resources? No. Our cloud is on our site, and your only extra computing resources could be one server for the data collection from boiler house, from the local SCADA system. When we take data from your local SCADA system, we installed a virtual machine on your local server, or put physical server with a UPS, and probably you already have some server inside your company. It's very small server. It's just a virtual machine with couple CPU and couple hundreds of memory, and only dedicated for the data collection.